I'm Jeff Silverman, and I am been working with computers since 1975, and I've been a system administrator of one sort or another since 1977. I have been working with computer networks, one form or another, since the late 1980s. So what I'm going to talk about is something I've been doing for a little bit. And so I want to talk about what happens under the hood, what happens inside a web browser. And I am approaching this from the point of view of how to diagnose and fix things when things go wrong. My expectation is that you are not going to be working on your own web browser or web browser internals, but that you will be using web browsers and you'll find yourself in a situation where they're failing. And I want to give you the tools and the troubleshooting techniques so that when the failure happens, you'll be able to diagnose it. The internet was designed to be proof against a nuclear bomb, and that's both a good thing and a bad thing. It's a good thing because the network tends to be reliable, and it's a bad thing because when it fails, first of all, it's hard to know when it is failing because frequently it fails degraded. And second of all, sometimes when it fails because there's redundancy, you don't know that it has failed, or it will tell you that something has gone wrong, and what it tells you is wrong. I would prefer that when you have a question to please stop me at the point where you have a question and ask. There are no stupid questions. That's actually not quite true, but it's close enough for the purposes of this discussion. If you want to get a copy of the this presentation, here's the URL for the slides. Yes, go ahead.
Should we be seeing the presentation?
Yes, you should be seeing the presentation.
Oh, you're going to put on duplicate.
This will be on YouTube, right?
Yeah.
It will be. But let me go just a
that
second.
will be on YouTube as well.
Yeah, you don't want to see a picture of a black hole. I mean, it's interesting in its own right, but that's not why we're here. Okay, now.
I thought that was just like your title slide or something.
Yeah. Okay, now.
I'll display configuration.
Okay. Now, great. Let me go back up here to slideshow. Okay, great. Now, there's the URL. And also the QR code on the first page also will take you there. So I discovered a Python module last week that will do QR codes. So if you want to do QR codes, you can do it in Python. It doesn't work well for large QRs. It'll go up to about 3,500 bytes and do it properly, but if you do it beyond that, it fails. So I was kind of annoyed about that because you can actually get a megabyte of data into a QR code if you've got proper software. At least that's what the standard says.
You have it locked down.
What?
You have it locked down, so you need permission.
Your presentation
needs permission.
You didn't share it.
Oh. Thank you.
Yeah, it's under general access. Yeah.
Okay, try it now. Is that better?
Yep.
Thank you.
Thank you.
So, let me, this is kind of an outline of what it is I want to talk about. URIs, URLs, URNs are acronyms. You don't see URIs or URNs very much anymore, but you see URLs all the time. So that's basically there, so that if you're looking at some of the older literature, you'll have some idea what it is they're talking about. The slide I want, that's really important is the URL with everything. And then the rest of the discussion basically is going to be about how to go and parse that URL, what the various parts mean, and then there'll be a discussion about TCP/IP layers and tools. So then that's the part that you need when you're going to be doing the troubleshooting. So a URI, Uniform Resource Identifier, tells you what a resource is without ambiguity, but it doesn't necessarily tell you how to get there. You can think of it as, for example, the address of a house, but it doesn't give you a map or instructions on how to get there. A uniform resource name is even less. It identifies a resource, but it doesn't tell you anything at all about it. So that would be like an address without knowing whether it's a house or a factory or a gas station or a telephone booth. Whereas a uniform a uniform resource locator gives you the name of a resource unambiguously, and it tells you how to get at it. So all URLs and URNs are URIs, but not all URNs are URLs. And URLs really are the thing that's useful, because it's not enough to know what something is, you also have to know how to get at it. So that's why you see URLs all the time, and you seldom see URNs or URIs anymore. It was a big deal when the internet first came out, and I don't see much discussion about it in the literature anymore. So basically the reason why I'm talking about it is that when you are looking through some of the older literature on the network, you'll have some idea of what these acronyms mean. So the only URLs that I'm going to talk about, the only schemes of URLs I'm going to talk about this afternoon is about things that you will encounter using your browser in your everyday use. There are some other schemes that I'll mention in passing, but you don't see those in browsers, or at least not very frequently. So the full syntax for a URL is the scheme, and then optionally a username and a password, which you should never ever use, but it's in there anyway, just in case. And then you need a way of separating the username password pair from the host. In TCP/IP, there are 65,536 possible ports that you can use. A lot of those are well known, and they're used for a specific purpose. And then there are thousands and thousands of them that are generally available for whatever use that you want. Then it's followed by a path, which is a logical file system, not necessarily a physical one. But it could be a physical one if the people running the web server want it to be. And if you're using a file scheme, then it is a file system. Then a query is really the bread and butter for the internet. When you are accessing a website, which is for a business or for some sort of active lookup, you're using queries instead of static content. When HTTP was first devised, they were thinking solely in terms of having static content. But fairly early on in the development of it, someone realized, oh, you could have a computer program that had a little bit more intelligence than just a static content server. So the first web servers really were what we would now call a content delivery network, or CDN. And the idea that you'd have something more sophisticated, that still is early on, but it wasn't the way it was originally envisioned. And finally, the anchor allows you to have a reference within a resource. So typically for a web page, that will be a ID or a, well, it's an ID. There is an ID attribute that you can apply to any HTML tag, and there's also an A tag, which will take a reference attribute, and that's something that an anchor will look for. Now, when I created this foil, originally that I was under the impression that URLs, that username and passwords had to be ASCII strings. I've been informed that in fact that's not true. You can use anything. For the host, normally it would be a name, and you would resolve it using DNS, and I'm going to go into a little bit more detail about DNS later in this discussion. Whether it uses IPv4 or IPv6 is a configuration item in your browser. It can use one or the other or both, and if it uses both, then you have to decide which one you're going to try first. And in theory, it's possible that you could do two queries, one in IPv4 and one in IPv6, and then go with whichever one answered first. I've never actually seen that done, but it's theoretically possible. Is everybody here familiar with the difference between IPv4 and IPv6?
Yes.
Okay, good. And I keep doing that. Okay. HTTP and HTTPS are the schemes that people think about most frequently when they're doing web browsers. File is also something that's commonly used for referencing a file in your own system. And you frequently use that for troubleshooting or making sure that your content works properly. Mail to is a way of having an email address in a web page, and most browsers these days have got a configuration so that when it encounters a mail to scheme, it will either go to a web-based email service such as Gmail or
Outlook.
thank you, Outlook. I was going to say Live, but yes, Outlook. That's something that you can set up in your browser. There is a plugin that I have seen for SSH, so that if you encounter an SSH scheme in a web page, it will start up a browser plugin, which is an SSH client, which I think is really pretty cool. But there are dozens of other schemes that are available. There's a page that IANA, the Internet Authority for the Internet Assigned Names Authority, which has a list of the schemes that are available. And there's nothing to stop you from creating your own scheme if you want to, although if you're so inclined to do something like that, I want you to think very carefully of why an existing scheme won't work for you. Here are the appropriate RFCs, requests for comments for URIs, URNs, and URLs. And then there have been some clarifications made over the years, because as we've been playing around with these things and discovered what works and what doesn't, people have been tweaking the system. And most of those things are clarifications, and basically when an ambiguity was discovered, it was a way of fixing it, or people coming up with best practices for these things. And a lot of it, the best practices improve on something that was working and make it work better in some ways. So one of the things about the internet is that it is constantly improving. It's very different now than what it was 30 years ago. And that's all to the good, because we haven't been stuck in place. We've been making progress. Sometimes not as quickly as I would like, but things are getting better, and I'm an incurable optimist. And I keep pushing the wrong button. And my mouse is working. Okay, so here are some examples of schemes that you will encounter in common use. So the first one is a reference to the home directory in my computer, and then I've got two different names for my web server, which is running on a little Raspberry Pi that I've got on a shelf underneath my table in my office. And then an example of how a mail to scheme would work. And this has what looks like a query, and I guess you could say it is, having the subject. And sometimes there have been a couple of occasions where someone has simply taken this foil and copied and pasted this third example and just plugged it into their mail. And so I know that someone is plagiarizing my presentation, and that flatters me like you would not believe. So Git will work over SSH, or it will work over its own protocol called Git. If you are on a trusted network, using the Git scheme is fine. If you're not working over a trusted network, then do not use the Git scheme because it's not encrypted. Use SSH instead. But otherwise, these are both perfectly fine ways of working with Git. All right, and just as a reminder, although you can put a username and a password in a URL, don't do it. It's just really a bad idea. Passwords are supposed to be a secret. If any of you were in the previous presentation that I gave this morning, where I asked everybody to go write down their password, nobody did it. I had 100% non-compliance, which was, I think, absolutely wonderful, because I told them to do something that they absolutely positively should not do. So don't do that. The problem with usernames is that they change. So you may have a system that's got a username that the user leaves, or someone else takes it over. So usernames are fungible. You should have an authentication scheme that's independent of a username. And the password is not an identifier, it's an authenticator. It is something that you know, and if you know it and no one else knows it, then you are authentically you. Whereas anybody who knows that password, they can authenticate it to you even though they're not authentically you, so don't do that. So then the question that often arises, people ask me, well, okay, so I need to go access this thing, but I don't have a username password pair, why can't I use my coworkers? And the answer is that you really should do things by the book, and if you need access to something, you should have a username and password pair that someone has authorized you to use, so that way you've got identification, authentication, and authorization. And those are kind of the three magic touchstones of secure computing. In this particular slide, the parenthetical comment, one of those O's, the first one is a lowercase o, and the second one is the Greek character omicron, and it's not an ASCII character, it's UTF-8, and there's no way in hell you can tell the difference by just looking at them which one is which, but they're different characters. And so that's one way of obfuscating something, but it's not an effective way of obfuscating something, because if I was to go and copy and paste that, the omicron would still be maintained in the copy and paste. So basically, using something other than ASCII is a recipe for confusion, or if you're really interested in internationalization in a serious way, in which case you should do internationalization properly and be consistent. So if you're going to use Greek letters throughout. The host name is this is backwards. It should be subdomain, domain, and then top level domain, host. So for example, in the previous slide where I had it, I am not doing well today at all. Okay, so in these particular URLs, Jeff Silver M and Jeff Silverman are the host name. DDNS is the domain name, and .net is the top level domain name. You can also use a local name for testing purposes. If you have a host that you want to test, but it's not necessarily in DNS, there is a file called /etc/hosts that you can enter the host name, and it will take a fully qualified domain name in it, and either an IPv4 or an IPv6 address. If you want to put an IPv4 address in, you can. If you want to put in an IPv6 address, then it has to be enclosed in square brackets. And the reason for that is that an IPv6 address might begin with a letter as opposed to a number. An IPv4 address always begins with a number. IPv6, that's not guaranteed. So if you put it in square brackets, then that will tell the browser that this is an IPv6 address. And then one of the things about IPv6, they're normally 128-bit IP addresses, but if you have 2 colons next to each other, that is a shorthand for a string of zeros. So the last example at the bottom, which is : FFFF, that's a way of encoding an IPv4 address inside of an IPv6 address. And the top, I want to say 48 bits are all zeros. And but instead of forcing you to type out all those zeros, you just put in the double colons, and it recognizes it as a string of zeros. So that makes life a lot easier when you're working with IPv6. So how does DNS actually work? DNS either stands for the domain name system or the distributed name system, or maybe both. They both begin with the letter D, so what? Everybody knows what it is. So when you type in a something with a host name, there is a system within the operating system in a library called libresolve.o, and it implements 2 library calls. One is getHostByName, which is obsolete now. That was for IPv4, and the other is getNameInfo, which is the current standard. And that will return not only an address, but it returns a whole bunch of other information that you might want about a host. So that's definitely what you should use if you're writing software that interfaces with the network at the low level. If you're working on a higher level, you don't need to worry about that because the library that you're using is going to call either getHostByName if it's old or getNameInfo if it's new. So in this particular case, if I'm looking at jeffsilverm.ddns.net, it's going to go to my resolver. Now, my resolver doesn't know what jeffsilverm.ddns.net is because it's not in my ITSI hosts file. So it's now going to make a DNS query to the resolver for my home network. And that resolver happens to be in my router. So it's going to have IP address 192.168.0.1. So my router's DNS server will either have that name cached or it won't. If it doesn't, then it's going to have to go to no IPs. It has to first go to a resolver for the .com top level domain to find out who is the name server for ddns.net. And so it will tell it that the resolver is nf1.no-ip.com, and it will give it its IPv4 address. And eventually it will find out, the resolver will ask no-IP's name server, who is jeffsilverm.ddns.net. It will return the current address, and then it will know to go to my particular machine. Now, the bottom part of these slides is how to go test this system. what I can do, show you a little bit about how this works. So if I go, first of all, if I just go, is this font big enough for people to see it? Okay.
Maybe bigger? Yeah.
Okay, thank you. I'm having trouble seeing it myself, but that's because I'm old and going blind. So if I just, this is the simple way. This is jeffsilverm.ddns.net. So this is, where do you go? Okay, so I'm doing something wrong here, but I don't know exactly what it is because I was expecting it to return an answer.
It was the M.
Oh, thank you. There we go.
Yeah.
There we go. So in this particular case, dig is returning my IPv4 address by default because I didn't give it a name type. If I wanted to find out the name server that is taking care of this, I would tell it -tns. So -t tells dig that it's looking for the name server type. And so it's got to go up to one of the root name servers to find out the name of the name server that is taking care of NoIP's customers. And so then now that I know that I need to go look up NF1, I can go and look at dig. So and this is NoIP's, one of NoIP's name servers. So if I want to go find out who NoIP's name servers are, I can go who am I no-ip.com, who, no, not who am I, who is. And so you can see they've got a list of 4 name servers. And then I can go, and they thoughtfully named it NS1 through NS4. So that's one of them. And they were hopefully in far enough separate networks so that if one network would go down, yeah, okay, so they're doing a good job of keeping things separated. That's good. So Microsoft once had all their name servers on one network, and they assumed that their network people were so good that that network would never go down. And one day someone made a configuration error in a router, and all of the routes to that network vanished, and Microsoft.com all of a sudden became inaccessible. So a far better scheme is don't be clever, put your name servers on different networks and keep them widely separated, because everybody makes mistakes. So you want to keep things simple. And I beg your pardon?
Humans are imperfect, we mess things up quite often.
Right. So, you know, that's why you should not hire human beings as system administrators. So, I was accosted by a bully a couple of weeks ago, and I said to him, "You can't talk to me like that." And he said, "Oh, yes, I can." I said, "No, you can." He said, "Why not?" "Because I'm a Linux system administrator." Oh. Oh. What's that? Well, you have to ask, maybe you shouldn't go say the things that you're kind of saying. Okay, he turns around and walks off. Anyway, okay, so when you make a TCP/IP connection, there is actually 4 numbers that form the connection. There is the source IP address, either IPv4 or IPv6, the source port, destination IP address, either IPv4 or IPv6, and destination port. And so any 2 computers can have tens of thousands of connections with one another, and because they're on different source ports and different destination ports, those connections can be kept separate. And that's part of the genius of TCP/IP. Some of those ports are well known, and you should not repurpose them. And then there are a whole bunch of them that are fair game for anything that you want to use. There is a file in your Linux computer called /etc/services, and that has a mapping of the well-known ports to services. Now, before you go tripping off in that file, I should point out to you that there are some services that have been renamed over time. And so what you are looking for might not be what's in there, or what you might think that what you're looking for is not in there. And that's because the name has changed. And so just to be prepared to be confused when you go through looking through /etc/services. So then, in the case of my web server, I took a bunch of pictures in Philadelphia in 2021, and so I've got this organized into a file tree of the pictures that I took. So that makes it easier to find things, because instead of having one big directory, I've got a relatively large number of relatively small directories, and that actually does make things go faster, simply because when you're traversing a directory, you have to go through it linearly. So having a real tree structure will make your website a little bit more efficient, and it makes it easier for humans to remember things. So I have been working with computers for a long time, and I've gotten to the point in my career where when things go right, I'm always pleasantly surprised. So the code for success is 200, and there are a couple of minor variations on 200, and I'm not going to go into them. But basically, any success code that begins with 200 is success, and you should feel happy and go on and do something else. 300 is for redirection. There's 301 and 302, which is temporary redirection and permanent redirection. But there are an awful lot of websites that get those meanings confused, or maybe it's permanent until it changes. So just take whether it's permanent or not permanent with a grain of salt. The book, RFC 2616, says that if you get a permanent redirect, the browser should cache that and never reference the old address ever again. In fact, what happens is that browsers never cache those responses, and so when you rename something or relocate something, the old address will continue to be looked at for all intents and purposes forever. So you really can't rely on browser caching to find your content. You're always going to have something that returns the 301 redirect. And so when you're designing your website, just keep that in mind. Once you've established a URL for something, there's got to be some way of recovering from that. Because otherwise you'll get the dreaded 404 error, which means it's not found. The 400 errors are when something has gone wrong on the client side, or at least that's what the book says. So 404 is the one that's most common when you're looking for something and it can't find it. 403 is when something is forbidden. 401 is when it's asking for further authentication. My favorite one is oh brother, block 451, which is brand new. That is content that's been forbidden by edict or by law. And that is from the book Fahrenheit 451. And it was kind of the IETF really had a lot of heartburn with that one because they really felt that knowledge should be unfettered. But there are other people out there whose, I'll be charitable and say their intent is nefarious. And they wanted this content prohibited. And so the IETF finally came up with 451 for content that someone has ruled that you are not supposed to have by law or by rule. And so that was blessed, and evidently everybody who knew what 451 actually was kept quiet about it. And then once it got out, somebody who was not part of the IETF spoke up and said, hey, wait a second, that's from this book, Fahrenheit 451, which is this dystopian science fiction novel about a fireman who doesn't put out fires but actually creates fires and destroys books. We've been snookered by the IETF, and the IETF kind of said, yeah, happens that way.
In Berlin Square, there's
I beg your pardon?
in Berlin Square, there's a piece of glass in the ground. If you look down, it's a library with a bunch of ashes in the middle. And the inscription says, first they burn the books, then they burn the people.
Where was this?
In Berlin Square in Germany.
I like that.
Yeah.
Okay. In the presentation I gave this morning, I had a picture in the slide about a book burning, but I think that particular one was in Czechoslovakia, but it was still being done by the Nazis as part of World War II. So code 500 are for server failures of all kinds, and what I like to tell my students is that your server should never, ever, ever send a 500 server-side failure. And if it does, you should have some software that's monitoring your server that pages you if your server is returning 500 errors, because that's a message that something is seriously wrong. And you, as the system administrator or the webmaster, are responsible for getting that thing fixed right away. So you should never see 500 errors, and when you do see 500 errors, you should treat them as very serious problems. So typically that means that, for example, a database connection is failing, or a computer program that your server relies on is crashing. The server itself is probably okay, because if something actually happens to the web server, you won't get any response at all. That's probably also a pageable event, but web servers these days are pretty reliable. You can make them crash if you work at it, but you have to work at it.
So I'm gonna have to rush you a little bit. You're technically supposed to end at 3:15, but I think I can let you go over, but just
Okay,
lock in.
thank you. Okay, so for queries, this is an example of a little demonstration that I wrote. It is a simple name server, and you're welcome to go try it out. That's very simple. So the first one, I have specified a name and setting my name to be Jeff, and the second one, I'm querying it to see what it returns. And the server is keeping the answer in memory. So if more than one person is accessing it at the same time, they're going to get different answers. And it's just designed to be very, very simple. The traditional tool for testing web servers is something called curl, and it's very popular, and I frequently use it simply because I've been using it for decades. But there are other tools that are better. It's virtual query. So HTTPS is written in Python, and my recommendation is that you go and get it from PyPy, as opposed to getting it from Canonical if you're running Ubuntu or a Snap store. Since simply because the up-to-date version is on PyPy. And so it's got a much nicer syntax. It's much easier to script things. And it gets especially easier when you're using more complicated queries where you're sending JSON or XML as part of the query. So I could give a whole class on HTML forms, and I'm just not going to do that. But suffice to say that forms are really is where our bread is buttered as webmasters and system administrators, because that's how the people that are using our websites are accessing the content. That's how they make our websites do what they do. Cookies are, HTTP is a stateless protocol, but there are all sorts of use cases for having state. Basically, if you're shopping at a store, your contents of your shopping cart is state. And so cookies were invented, and cookies are kind of a mixed blessing in the way they're implemented. It is possible to store the entire state of a shopping cart in a single cookie. The way that I'm doing it, which I think is really reliable, is using something called a Global User Identifier, or GUID, or a Universal User Identifier, which is a UUID. And there are basically two different words for the same thing. GUID and UUID are basically the same thing. I create a GUID, send it out as a cookie, and then that GUID is a pointer to a record in a database on my server, which is the state of the shopping cart. So if a bad guy was to go and corrupt the GUID that I sent it, it is incredibly unlikely that they would hit a valid record. More likely that they would break something, far more likely. And that way they can mess around with cookies to their heart's content, and it won't tell them anything. And then when they buy something else and put it in the shopping cart, the state has changed. I generate a new GUID, the old GUID I never ever use again. And that's a very reliable way of doing something. It's actually kind of overkill, because a GUID is 128 bits, and you really don't need anything that long, but it's well documented and it's reliable, and there's no reason not to. So here are some URLs for some tests to see how well your web server is working in terms of its performance. And performance matters for an awful lot of applications. For my particular website, I don't care. So I'm running it on a little Raspberry Pi that I picked up at a flea market for $50. But I'm a cheap person. So I really wanted to go into protocols and troubleshooting tools, and I'm running out of time. But basically, this is the infamous OSI 7-layer stack, and in the far right-hand column are the tools that you use for testing things at the various levels. And so I showed you dig, which is at level 7, and HTTPS and curl. Those are all level 7 tools. They're also useful at level 6. I didn't really go into SSL dump or SSL LYZE or OpenSSL. I could give a class on those, and in fact I have. And TCP dump, Wireshark, T-Shark, those are all tools for troubleshooting at a really very, very low level. And you don't need to know those tools until you do. And every once in a while you come across a problem where you just have to go see what's going on in the wire, and then at that point you're going to need to know how to use Wireshark or T-Shark or TCP dump. And if you have to learn one of the three of them, then learn Wireshark, because it's got a graphical user interface and a really good decoding system.
So I'm gonna need you to start wrapping it up.
All right. Time and tide wait for no man. Okay, so, this page is some of the previous presentations that I've given here at Linux Fest or at Seagull. And a lot of these things are still under active development in my copious spare time. So if you've got questions about this, then I would like you to, don't hesitate to email me. And now that I want to get to the very front, I'm trying to figure out how to do that. There. Okay, so, you know, I love to talk about this stuff. Once I get up and start talking about it, it's very difficult for me to shut up and sit down, but several people wish I would. One of whom is my wife, who can't tell TCP/IP from a tin can telephone. She's just not technical, but she laughs at my jokes, which after 42 years really says something about her. I'm just not sure what. But anyway, if you've got questions, please do not hesitate to call me. If you have trouble with the URLs, if there's anything I can do to make things clear, the whole point behind going to Linux Fest is to connect people up with experts, and there's never enough time to talk about all the things that we want to talk about. But, you know, you're doing a good job of keeping me on track, and I appreciate it, even though it's a bloody pain in the neck.
I never end.
Yeah, okay. Thank you very much for being in such a wonderful audience. I really appreciate it.